Slowly or quickly?
I don't know.
Well, do get better. All right, yes.
What's the IP address to SSH?
It's the same one it's always been that has now been erased from the board. It is 192.168.208.84, and the username is student, and the password is the incredibly secure student as well.
What's the full website?
The full what?
Website? Or is it just the address?
No, just go to the IP address. I did not make a DNS entry. Okay, so let's come up with an idea of what binary search would be. I'll call it vsearch. Ooh, look at that. Const int array. And we'll do const int size. All right. You know, I just realized that we could do this iteratively or recursively. Ooh. Well, let's come up with at least a quick test case first.
Probably good.
And hey. All right, someone type that out on the board. Yeah, that was beautiful. You could put other numbers too, by the way.
Do you want me to?
If you want to, as long as they're sorted.
I don't really want to.
Then don't. Oh, okay, great. Int size equals, how many elements is that? 1, 2, 3, 4, 5, 6, 7, 8. Great. And then with search of ARY and size. And did I insert? Good. I include IO stream. Yeah, let's make sure this compiles. Oh, look, I have a singly linked list. Whatever. Hey, no return statement. All right, return -1. So we'll say this. Ooh, let me spell returns. Returns the index of. Hey, look, we didn't pass it what the key is. That's cute. In the array. Returns -1 if not found. Okay. So what key do we want to search for? Hey, the 5. Okay, sure. All right. How do you want to code this? Y'all did recursion in OOP, right? Right? Good. So I'll just assume you're all recursive masters at this point.
We're just the best.
We were
no
the
one
best.
else is better than us. I
Yeah.
think.
Yeah, after once.
Yep.
Henderson is the master at the recursive. Great. Perfect. So let's do this recursively.
It's like being taught by you.
Yeah. Oh, wow.
Not that way. No, not gold and green.
There's a phrase called quitting while one's ahead.
I refuse to.
I don't think you understand me completely yet, so he's doing great.
Alright, sure.
Maybe I should say you underestimate my ego. Maybe that's a better way to put it. But anyways, so if you're doing if we're going to do this recursively, whenever you write a recursive function, as Henderson probably told you, you want to write your base case first. So let's do, the base case. Now, the base case is when does this recursive function exit? And sometimes it can be hard to know when that's the case, so you may have to write the rest of the recursive function first, or you can write it right now. But there should be a couple things that pop out for you. One, if the array is null, that would be bad. Or if size was
0
or less than 1, yeah, 0 or less than 1. Yeah, you're right. So let's go put those in. If ARY equals null or size is less than 1, we're going to return -1 because that means it wasn't found, because how can you find an item in an array that doesn't exist. So that makes sense. All right. Now write the function. All right, I'm sorry. Now you can continue. Now I'll just say now continue for now.
Do the thing.
Do the thing. Do it. I'm trying to think of the
Do
best way
thing, do it right.
to say it without giving it away what needs to happen. All right, so we have our function. It has a guard, and guards are great things to write right off the bat, especially when you have to submit it to Dr. West's autograder, which is going to throw null at everything that you try to do. One of the first things I test, just so you know. All right, so what happens? So what do we need to do?
Jump to the middle.
Jump to the middle. So how do we find out what the middle is?
Size divided by 2.
All right, let's go do that. No, you're doing great. I'm going to help you out, okay?
Yes.
All right, yeah, so if it's actually right there, we're done. Great. Okay. Well, that makes that part easy. But now, what if it's not there? So the next,
So
the next thing we need to check if it's greater than or less than, right? So let's do that. So that's why I was saying that there's actually two checks. It's the same thing, the same if statement, but you're going to do less than or greater than depending on which way you want to do it. Right, so if it's so that means that the key is less than, so then yeah, you're gonna do a B search from array, yeah, and what size?
Size divided by 4.
Not 4. Let's go to the board real quick, and I love how you can just type this out while I'm on the board. So currently we're from size, this is where the implementation can get tricky. I'm going to call this index, and I'm going to make a line so you understand that these two things are different. 0, 1, 2, 3, 4, 5, 6, 7, because this, and the size is 8. All right, so 8 divided by 2 is 4, so we favorite the greater, which is fine. There's no problem with that. 4, and so now we want to search this part, right, from 0 to 3. So it's really size divided by 2, which is 4, minus, because we don't need to search this guy again, do we? No, so we go ahead and subtract 1, right? Size divided by 2 is here, and then we subtract 1. And hold on, let me drive real quick. One thing that can be very, very helpful is to create a variable mid position. And we'll make that size divided by 2. That way I can go here and I can just do mid position. And I don't have to type that all out. And also if I ever decide to change what mid position should be, you could have called it mid. I'm making mid position so it's clear. Middle position, I should say. Then down here, it's just mid position minus 1, and now all the other math has been done correctly. You already saved it, and you're good to go. By the way, just so you know, that's what the compiler does anyways, when it takes your code and translates it into machine. Perfect. Semicolon. All right, and now for the harder one. Oh, well, you don't just call B search, you return it. I think that's what you meant. Otherwise, actually, let's make this, there are different ways you can put in the else statement, or we can just have the last call be it, and sometimes it's easier if you just make the last call because then the compiler won't complain. But if it's not less than, then it must be greater than. So now we need to call, this is the tricky part. Because now what's happening, B search, okay, array, size, or you mean mid position? It's still mid position minus 1. That's what's going to be tricky here. Because it's mid position here minus 1 because all these elements, kind of, sort of. We're going to have to fix this up in a moment. But the problem is, if you do that, you're going to search these elements when you mean to search those elements. How can we change which elements we're searching?
Add. Add.
Add, yep, great. Add to what?
The index.
The index. Okay, yeah, add to the index that you're starting, right? Right. How can we change that? Well, what's array? What is its type?
Int.
Well, it's not just an int. It's a pointer. And where is it currently pointing?
The first.
To the first element. Are we allowed to change that?
We can create a variable to change it.
Right. And have it point to where?
The middle.
The middle, where we want to go. Where can we do that? Right here. Right? Because that's where the array is. So we need to say where the midsection is going to be. Mid position. So that would point to the 1. That's not quite what we want. That would point back to the 0.
Oh, plus 1.
Yeah, plus 1. Yeah. There we go. Yeah, that'll work. We don't need the parentheses, but that's fine. Okay. Almost there. Remember, binary search is going to return the index within it. So once it returns the index within here, it's only going to return that number, but we need to add everything up to that point, right? So it's not, you're not returning just binary search. You're actually returning position plus 1 plus binary search. And I think we forgot our last ending. There we go. All right, a little complicated. Let's see if any of this works though, which might be curious, yes? Good call. Let's see if the compiler complains at me. No, okay, great. -1, what were we searching for? Searching for 5, which did exist, which means our algorithm is not correct. Oh. All right, let's see what happens. Yeah, that's a problem. Okay, let's go see what happens.
-1's not even in the array, so that's even better.
Remember, it's returning the index of the value. So 5 should have returned 5 because that's its index. Am I on the board? No, I'm not. All right, let's go take a look. Okay, so we favored the greater one, I believe. So when we did size, we would start here, check if it's equal to that, and it's not. So then we would jump over to what, middle position plus 1, and then we point arrow to go right here, and then we check the 27. If it's equal to that, which it's not, we then pass arrow middle position. Well, hold on a second, that's 3. 3 divided by 2 is 1. Great. So we did middle position minus 1. And, ooh, because 1 minus 1 is 0, and then our base case would have returned -1. Yep, that's not right. So, oh, I'm sorry, I did that all real quickly. So, let me make it, let's see how to draw this because it's recursive. Let's go search ARY points here. The size is 8, and the key we're looking for is 5. Right? That's the first one. In that case, mid equals 4, and then we call B search with ARY pointing to whoops, here. That was beautiful. Mid, what do we say? What did we call that? Mid position -1, so the size is 3, which is correct, and we're looking for 5. Okay? Everyone following me so far? Great. So now mid equals, well, it's 3 divided by 2, which is 1. This time, it's not, it's going to be less than, so we're going to call B search, this time on array, pointing to this guy, and size is going to be 1 minus 1, which is 0. Uh-oh. Y'all see what happened? And now our base case, since size is less than 1, we go ahead and return -1, even though we really need to check that position. How can we get around this? I guess we could band-aid it and check if size is equal to 0. Well, I think I might have led you a little astray, and that might have been my fault. If we're right here at 4, and we want to search the previous from 0 to 3, what's the size of that?
4.
It's actually 4. So if you're going less than, you actually don't subtract the 1. And I think I told you the other way around. But that's okay, because then you get to see how things work. And then, but on this case, if it's greater than 0, 1, 2, 3, yeah, so we don't need to subtract because the size is how big it is in this case. I had the other version in my mind. That's fine. But good old debugging. So now the real question is, welcome back. Is this correct? It looks correct because you actually do have to jump 1 over. All right, let's go ahead and, ooh, still -1. That's not good. Well, it's -1 and you don't see what's going on. Let's print it out. Oops. For int I equals 0, I is less than size, I plus plus. And we're not doing C plus C, we're doing C plus plus. All right, so, well, that's not good. It keeps going to the lower half. Well, that might be the real problem here. So I'm printing it out on every iteration. The first iteration has the whole array, and then it goes to the lower part, even though 5 is the other way around. Well, 5 is greater than this position. Oh yeah, we have this backwards. Ah. Well, that's funny. Hey, found it.
There it goes.
Ooh, that's cute.
What is the other number?
That's not good.
It doesn't like that.
Looks like we've.
Because you did position on one of those.
Yeah, hold on a second. Did we?
On the mid position on the last return statement.
Right. So if it's greater than, it looks like that worked out well, but this one did not.
That does need -1.
All right.
Because then it's only 3 instead of 4.
Oh, good. Much better. Whew. Okay. Well, now let's see if we can break it. Yes, because that was not completely broken. Let's add another number, 84. Let's see if that messes anything up. Nope. I found that pretty, well, we probably should also increase size.
Yeah. Pretty good idea.
Whatever. Details. Oh, I like that. Good. And maybe I should ask for another number. How about 84? Let's see if we can go to the end. Positions. Wait, 6? 84 is not at 6. Uh-oh. We broke it.
Cool.
Yeah. All right, what do we do wrong?
Lot.
A lot? Oh, it can't be a lot. We're getting, you know, at least we found out it's in there, right? Position, it should be at 8, right? It should be at 8, but we're getting back 6. Well, that's not good. Oh, let me also update this in case we decide to change things later. All right, well, God, see how to, man, I am so used to C. Let's see. Adding, so we're just saying here what's actually being added. And that'll tell us what numbers we're actually supposed to be adding to it. Adding 5, adding 2, and then, well, then that would imply it needs to at least be 7, but for some reason, when it adds the next one, it's not actually adding it?
Oh, it's because it's an on, and we did position -1. That only works for if it's an even array.
Yep, there it is. Y'all see what I'm going on here? All right.
That's awesome.
Yep, now for even more funness. So, let's go look at this. On the board? No. Wow, that marker is done.
Just gave up halfway in.
Yeah, I'm done. Hey,
Like, you know what? I'm ready to retire.
I'm done. All right. So let's see what we did here. And 9, right? 9. Whoops. The size is 9, and the thing we're looking for is 84. Perfect. So, what's 9 divided by 2? Sorry. 4. Right there. Yeah. I'll keep going. So mid equals 4. It's on the greater half, right? So then we need to do, oh boy. So if it's on the greater half, there we go. So then we're going to call B search of array pointing to the 5. And we passed, what, we just passed mid? And then we're still looking for 84, is that correct? 1, 2, 3, 4. That looks correct, kind of. But last time we passed 3. Hold on a second. So if, no, so we're down here. So we're passing array plus the mid, that's correct. But now we're doing mid position -1. Why do we do -1?
For the
because for the even array, right?
Yes.
Yes. So this time, if it's odd, we don't want to subtract 1. Fun. Well, luckily it's easy to do that. Int off, let's go with even offset equals size mod 2. Let's see. So size mod 2 will tell you if it's even. Well, it will return 0 if it's even, and then 1 if it's odd. Fortunately, we want that to be the other way around because of what I'm going to do. So I'm going to add 1 to size. Ooh. And then down here, even offset. So now, if it's even, it'll subtract 1. If it's odd, it won't subtract 1. Sometimes it gets very complicated. That's why we're doing this in class. And I'm not making you do this one. Although it was tempting. All right, let's see if it actually works, though. Because it might not. Hey, 8, perfect. All right, let's go back down here and go back to 8, size of 8, and searching for 5, if that still works. Hey, that still works. Okay, great. All right, how's everyone doing? So that's the recursive version of binary search. We could do the iterative version as well, where you put it inside of a while loop, and you just pick where start and end is, and then you have to manipulate your start end. You're still going to have to do this even odd trick, by the way. That doesn't go away. It's just written differently. All right. I'm going to go ahead and remove these print statements. Hey, there we go. There's the whole function that we wrote. And we don't need to write this adding thing. Okay. I like to stop here and ask the class, what do y'all think of the recursion at this point?
I've always been mixed on recursion. Like it definitely has very useful aspects.
It's a lot of
Sometimes
typing.
it's just so annoying to do.
It's so annoying to do. Okay.
It's a lot of typing for a very small result.
Very small result. Okay.
Less payout, there it is.
So you don't think the payout's worth it yet, which I can understand. You okay, Amber?
There's a bug.
Oh, there's a bug.
Quite literally, not the computer side.
I've just learned over time that for some reason bugs and females.
He's hiding.
I mean, that was totally sexist, 100%. See, I don't care, right? I just don't care. You probably don't want to shake my hand now.
There's Germans by your computer.
Oh, okay, sure. Hey, I wonder if that actually works. I bet you it doesn't. Nope. Yeah, oh well. Hey, do we have wipes? I have a napkin. All right, don't shake my hand. And now I'll type my keyboard. So that way, if I type on my keyboard, you know not to shake my, no. Anyways. All right, so it doesn't seem like a lot of payout right now. But it's important to start thinking about it because when we get to binary trees, there's going to be a huge return on investment. Yes, ma'am. Notice I didn't say I wanted to. I just said yes, ma'am. Thank you. Okay. That was fun. All right, I think that's all for binary search. Let's go ahead